Fine. So let us do questions on derivatives, or let me just explain the concept of derivatives, right?
Let's do the concept. Yeah.
Yeah, okay. Concept. So before derivatives, you should know the concept of limits. Yeah, because derivatives is the basically second unit when it comes to calculus. Calculus is a separate branch of mathematics which deals with the rate of changes,
Okay.
right? And then this is the base of calculus. If you know limits, then you can easily do derivatives. Okay. If like maybe if you're not aware of the term, have you seen this thing before? X is approaching, say, 0 and this. Have you seen that?
I've seen the 1/x before. It's like a reciprocal, not a reciprocal graph, but like as a graph before. I've seen 1/x.
Okay. Okay, because we know now that, see, what is the concept like when I'm saying the limits? Let me give you a little idea. Okay, why do we study limits and then why do we need derivatives? Limit is the concept, as you know, if suppose I'm just talking about a function f of x is equal to 1 by x. We know that this function is defined at all real values except at x equal to 0.
Yes.
Right? So x not equal to 0, then yes, we accept this function. Why? Because in the denominator, if x is 0, denominator is 0, function is not defined.
Yeah, your
So,
voice is really echoey.
is it? Okay.
Yes, it's quite
Give me
echoey.
a minute. Give me a minute. Is it better now?
Yeah, it's a bit better.
Yeah. Okay. So the thing is, we know that this function is not defined when x is 0. But what if I am interested to know what is the behavior of this function when x is very close to 0? Okay. So that way, for example, like I know x equal to 0, it is not defined. But when x is approaching 0, it happens from left hand side. You know, there are infinite numbers, real numbers, which are less than 0 and close to 0, right? And then there is right hand limit. That is, there are infinite numbers which are greater than 0, right? So
You're
I
close to
want to know the behavior of this function. So we talk about LHL, that is left hand limit, and I talk about RHL. So what does that mean? See, left hand limit means I am approaching 0. I am means x is approaching 0 from
Mhm.
left hand side of 0. This negative shows that even if you don't write LHL, but this negative sign shows that yes, you are approaching, x is approaching 0 from its left hand side. All right.
Okay.
Okay. So I want to know the behavior of this function. So what we do is I take values which are close to 0 from its left side. Basically, the negative numbers which are very close to 0. Okay.
Yeah.
Minus 0.1. So
Mm-hmm.
if I'm finding the value of this function at minus 0.1, what will we get? We are
Yeah.
going to get minus 10. Is that clear?
Okay. Yeah.
And this is f of x, sorry. Yeah. And same way, if suppose I go more close towards 0 from left hand side, let me take the value minus 0.01. Yeah.
Yeah.
Yes. So what is the answer? Minus 100. Yeah.
Yeah.
Same way, minus 0.001. Answer is minus 1000. And so. So what is happening from here? We can see that as we are decreasing the value of x, the output is increasing,
All right.
right? Same way, when we talk about right hand limit, now let me say, let me take 0.1. Answer is 10. Let me take 0.001. Answer basically the output, which we take along
Yes.
y-axis. So this is 1000. Let me take this. Answer is, output is 10,000. So again, what is happening as we are decreasing the value of x? Of course, we are decreasing the value of x. The output is increasing.
Okay, yeah. So as x, the value of x gets closer and closer to zero, then
Yes,
the value of your f of x increases exponentially. Okay.
yes. So why are we finding this? What is the need of it? The need is that we know that this function, though this function is not defined when x is 0, but at least we get to know an idea about the function when x is very close to 0. That's it. This is the need of this function. Not
Good.
function, limits. Okay. Why do we study limits and then derivatives? Basically, like Prabhu, you said that yesterday only, like you started derivatives. Can you just tell me what you did yesterday about derivatives, or what you have done so far in derivatives?
So first I found out like what's it called, like the general formula. So it was like
Okay.
nx to the power of n minus one, and you can use that to find out the formula of like when you have like quadratic or cubic or quadratic curve. You can use that to like find the what's it called, the gradient, or like the formula for the gradient of like the line where it's curving but it looks to be straight.
Yes. Yes. So basically, what you have done, you are saying that if suppose function is x raised to the power n, that is, I'm talking about the polynomial function basically, right? So when we find its derivative, it is f dash x, or we do denote it as, suppose this function is y, we do denote it by dy by dx, because derivative we are taking with respect to x. So you said that you get this. Am I
Yeah.
clear? Yes. Right. For example, if suppose the function is x raised to the power 5, and I ask you take its derivative with respect to x. Answer is
Okay.
this. Let me tell you, Prabhu, this is very easy to get the solutions, get the right answer of the questions wherever, whatever the functions are given. You will be doing logarithmic functions, exponential functions. It's very easy to get the answers. But the thing is, if you're studying rules, why is that rule there? What is the need of it? What this dy by dx is giving me? Can you tell me little bit about the geometrical meaning of dy by dx of any function? Like
Okay,
you're
so when
finding,
you right, well, I'm obviously still very new to all these things. Like, I don't really know much, but like when you say like dy over dx, you're talking about d being like the change of. So you're talking about your change in y over your change in x, essentially, and you would use
very
that as
good.
your notation
Yes.
for your whatever you're
Yes.
trying to find out.
So basically, dy by dx actually gives you as you said that it is the rate of change of y with respect to x. Like if a function is
Yes.
of, is depending on x, then we find rate of change. Basically, dy by dx or derivatives help you to find instantaneous rate of change. Instantaneous rate of change it gives you.
Hmm?
Instantaneous rate of change of which quantity? Of y with
Of y.
respect to
X.
x, right? With respect to x. Actually, say this, and in fact, when I was asking you what is the geometrical meaning, see, geometrical meaning is little different. What is this? We talk about geometrical meaning of derivative is that it gives you the slope of tangent at a particular point on the curve. At a particular point on the curve. Have you heard this before? Or shall I put some light over it? Slope
So
of
the
tangent?
slope of the tangent. So you have your curve. You draw a
Yeah.
tangent at the curve. So
Yes.
what do you mean when you're talking about the slope of the tangent? So does that just mean like the gradient? Oh, the gradient of the tangent. Fine. Okay, no, that makes sense.
Yes. And this is how, say this, what happens? Like you are talking about curve, right? Say
Hmm.
this, suppose this is the curve, okay? I'm in, here is this point, say A, and this point is B. Of course, coordinate geometry, like you can say x1, y1,
Yeah.
x2, y2. Now, this is all understood. Like these are just different notations, like y equal to f of x. And now this is a quadratic function, I don't know. I'm just writing in general.
Okay.
Yes. Now,
Yeah.
okay. So when I'm saying x1, y1, it is understood that these coordinates are same as this. Is this clear? Because y1 is nothing but the output of the function
Oh, I've got an
when,
X, yes.
yeah, right?
Yeah.
Same way, when we are talking about this point, it is again understood y2 is nothing but the value of the function at x2.
Okay.
Yeah. Now see what happens. Like if I talk about this curve, I draw a line joining